We are looking at question number 9, and again, we have fraction here. In this question, we have 9 over 6 equals to x over 8, and the goal is to try to solve for x. Let me make some notes about fractions. So again, I will just put on some notes that we'll use for the question, and later on you will find more videos, and I'll go over more simple questions. So let's see, note. So I will just write down the formula first. Let's say if I have two fractions. Let's say the first one is a over b. That's equals to second fraction c over d. If you have two fractions that they are equal to each other, what you must have is also that when you take a times d, and in algebra, we write that as a d. This means a times d. If you take a times d, this number times this number, that will have to be the same as if you take c and multiply by d, b. AD must equal to BC. Let's write B first, C later. So this relationship is called the cross product property. So let me do a real quick example. Let's talk about fractions that we're familiar with. 1/2. Well, 1/2, we also see that it's equal to 5 over 10, right? So we know 1/2 is equal to 5 over 10 because this is like 0.5. They are equal. Let's verify this property. If we take 1, multiply by 10. So I have 1, and let me write it times 10. Is that the same as saying 5 times 2 or 2 times 5? Let me see. I take the 2 and then multiply by the 5. And notice the order of multiplication doesn't matter. So BC, CB doesn't matter. 5 times 2, 2 times 5 doesn't matter. Let me put it as 2 times 5. 2 times 5. Well, 1 times 10 is 10. 2 times 5 is 10 as well, right? And let me look at another example. Let's do 3 over 8. I want to check if that's equal to 9 over 24. Well, let's see. I just need to do 3 times 24. So I'll do 3 times 24. If that's the same as saying 9 times 8, when 8 times 9. If that's the same as saying 8 times 9. If this is the same, then 3 over 8 will be the same as 9 over 24. Well, if you just do a multiplication, 3 times 24 is 72. 8 times 9 is also 72. So they're equal. If this is equal, then these two fractions are equal. So actually, it's like going backwards, forwards, and backwards. Okay, so maybe this example is, you think that it's kind of too easy, right? Like, when are we going to use this? It's when the time that we want to solve for x, to make the proportion the same. Here, number 9. I have 9 over 6. I want to make sure that that's equal to x over 8. So what we're going to do is, we're going to do the cross product property. When you have the proportion, when you have two fractions equal to each other, let's take 9 times 8. That's my first step. So 9 times 8, let me write it down steps. 9 times 8. And notice that this is my little baby x. Okay, and that's my variable x. This little baby x indicates that we are multiplying. Okay. I want to set this equal to 6 times x. So 6, baby x, and then the variable x. So right here, 9 times 8, it's 72. That's equal to 6 times x. Let me just write this, 6x. Right? Because in algebra, the multiplication symbol will be just like it's understood that if you don't have any operation in between of the number and the variable, 6x means 6 times x. Okay, 72 is equal to 6 times x. What's x? So right here you have 6 times x. What we're going to do is do the opposite. The opposite of multiplication is division. We are going to divide by 6 on both sides. Divide by 6 on both sides. 6 and this is, the 6 in black and the 6 in red, they cancel each other out. And right here I have 72. Divide by 6, that's equal to 12. Equals 2. Now on the right hand side, I just have the x. So 12 is equal to x, x is equal to 12. Let me take a look. And that's answer choice E. Right? We get x is equal to 12, and that's the value of x that we are looking for. So answer choice